So today I'm talking to Berkin Arikan. I got that right? Close enough?
Perfect.
All right, great. He's with HydroMX, and I found out about this product a couple months ago, and I thought it was kind of intriguing because this is a different technology from traditional glycols, guys. So this has to do with, you're running, there's gazillions of systems out there that are running propylene glycol, ethylene glycol, PG, EG.
Or water.
And, yeah, I thought this was a really interesting product because it's based on nanotechnology, and nanotechnology is very interesting. We, back in my chiller days, we used to build process chillers for companies that develop nanotechnology products. Anyway, so Berkin, welcome to the show, and tell me, give us a little bio on you and tell us about, how HydroMX came about.
Absolutely. Thanks for having me, Martin.
You bet.
Well, making a elevator pitch. What HydroMX is? HydroMX is a nanotechnology product. It's a nano fluid, and I was doing a lot of business consulting in Europe, and they hired me as a consultant, HydroMX, back when I was in Europe. And first, believe it or not, I had very much interest in nanotechnology back in the day when we had the oil factory, my father and I. And I knew a lot of things about nanos, but back in the day, they were super expensive. This is 2008, 2009. As technology advances, so is the making of nanoparticles became super cheap now. Back in the day, it was super expensive. So we pretty much didn't do much, but I learned a great deal of them. And when they introduced my technology, I said, too good to be true, right? They cannot do the things that they're claiming they will do. So, well, it became true. I invested in a company, my capital, and we became an American company. Now we have a factory in New York. We're New York based in Queens. We have a couple of offices in the city. And this became one of the leading technologies for HVAC industry to fight carbon emissions. So that's where I guess the whole conversation pretty much boiled down to. And because HVAC industry is reached limits, where they can go from here is nobody knows. So we're looking at other technologies besides the HVAC. So now we're in the heat transfer business, because every HVAC unit at the end of the day is a heat exchanger, right? Mm-hmm. So that's where we add a lot of value and reduce consumption of the associated HVAC equipment.
So this product is a drop-in, if you will, for let's say create a scenario here. You've got a data center, you've got a commercial office building, something like that, that's running a large tonnage, 500 and up, centrifugal chiller, and what you're saying is this nanotechnology, you have the ability to drain down the existing glycol, whether it be PG or EG in these systems, and drop in your product at the same concentrations pretty much, and they'll be able to achieve what as far as improvements in
absolutely.
Yeah.
Yep. Martin, we're not only beating glycol, we're beating water. Mm-hmm. So we do have a environment product declaration document, which was all the data was verified and certified by a panel of experts led by a gentleman, professor by the name of Thomas Gloria, who happens to be the director of Harvard University. Uh-huh. Well, the technology or the science behind HydroMX is well known to the world. There are main hurdles with the technology, not with the product, but the technology. And the first main problem is the toxicology. It's not that the nanofluids work. They all work to a certain extent, but can they clear toxicology guidelines put forward by FDA? That's the key. We're the only nanofluid company on the planet that cleared FDA regulations. And that is we're the only commercial one out there.
So you could literally dump this stuff down the drain and you don't have an issue, huh?
Well, yeah, ethylene you cannot dump down the drain, but propylene, HydroMX, yes, you can just drain it. As a matter of fact, not only can drain it, but we have incidental food contact clearance.
Mhm.
That means if a certain amount of HydroMX drops to your meal, you can eat it.
Right. Well,
I did one time, but
yeah, that's good. That's so interesting. So, yeah, I'm looking at your website here, and what kind of caught my eye when I was doing the workup for this show was your case studies, right? And you've got a lot of them in here, surprisingly. You've got office buildings, data centers, government and public, healthcare and schools.
yeah,
How
Martin,
many?
this case studies that we have here, not
Yeah.
all our installations. Obviously, we have hundreds of installations globally,
Mhm.
and believe it or not, only India now we have over 50 case studies.
Mhm.
And the reason India is kind of become a workhorse, India did not require the stringent FDA regulations clearance, so India had a kind of lead start on US.
Mhm.
So, and we're not, as you see, we're not sharing any Indian case studies here.
Right.
Well, again, with toxicology, the main hurdle is the engineering society. Engineering
Sure.
society, yeah, that's is a big problem with new technologies.
Yeah,
There's been one.
I get it because I guess your challenge is making connection with what I call early adopters, right? So these are individuals that, are open to, taking the risk, if you will, of going in with a newer product. Glycols have been around, glycol heat transfer fluid in the mechanical world have been around forever. And it's pretty widely accepted that, this is what you use if you want to have freeze protection, right?
Yep.
And so I get it. I have a patent on economizer technology for process chillers.
Beautiful.
And it just took forever to get, the
Yeah.
engineering community to accept it, right? It's tough.
With nanotechnology, there are, if I may, I have every word you're saying, I have maybe 10 sentences to add, unfortunately, because I'm sitting in the committees in New York for new technology, fight carbon, right? New York's biggest carbon generator is the buildings, not the cars, right?
Mhm.
And Manhattan obviously has major problems, and now that the government is telling all the building owners to reduce their carbons, they don't know how. How in the world a building, it doesn't have to be as big as Empire State, right? 1/10, any building over 50,000 square feet. How are they going to do it, right? This is why we come in, the new technologies, and engineers, unfortunately, they're still looking at the old books. The formula for a nano fluid efficiency was written by a gentleman named Maxwell in 1881. And they're still using the same formula, which has nothing to do with what we do. Back then, they didn't have nanoparticles. They had micron level particles at best.
So, Berkin, what you're talking about, though, when you say carbon footprint, let me make sure that I'm understanding this correctly. So what you're referring to is the increase in heat transfer will reduce the runtime hours on the equipment. So less energy consumed means less energy needing to be generated, and so on. So that's the key of what you're talking about when you're saying carbon footprint, right?
I can give you examples if you want. For example, you have we're right now in the state of Minnesota. One of our investor companies are operating. They graciously, state of Minnesota, put aside good chunk of money to test HydroMX, right? The first installation was in a government building on the chiller application. One chiller, dedicated chiller to one air handling unit. Simple. It could not be simpler than this. Okay.
Is it this one on the
that's the runoff loop.
Right
that's
here?
the heat recovery loop. That's the heat recovery loop, for example.
Okay.
There's no heater, just a straight heat exchanger interaction. So in this case study, I'm going to wrap it up really, really easy for you. You have a chiller, pumps up, 44-degree water, right? 54, 44, that's the setup. Goes directly to an air handling unit, only serves one area, one space. What you're seeing with HydroMX is increased delta T on the air handling unit. So what happens? The Q famous Q calculation, mass times delta T times, right? Specific in this case, there's no specific because it's water to air. So you have CFM times delta T is your BTU pretty much, right? So you have the same BTU with what now? Less fluid because delta T is wider, right? So what happens? The return temperature, return fluid, bypass valve closes down, return temperature to return fluid is now cooler, so delta T on your chiller is lower. What happens? Your chiller runs less.
Okay.
This is one of the scenarios that once the engineers hired by the state of Minnesota saw this, they could not believe it. They understood, oh, now we know what you're doing. So behavior of the chiller changed, air handling unit changed, even in some terms, CFM of the air handling unit decreased because they were satisfying the room and at a faster pace because of the wider delta T's.
Well, and that actually, well, this is kind of making my head spin a little bit, right? So
I knew
yeah,
it.
so yeah, if you have less runtime on a chiller, fully loaded chiller, if you have less runtime on it, then I guess in theory, I mean, you guys haven't been around long enough to really probably capture this data, but you know, according to ASHRAE, these mechanical machines will last 15 to 18 years, obviously longer if they're you know, well maintained. So in theory, if they're running less, then there's sort of then you have a reduction in not only reduction in energy usage, carbon footprint, but I guess you could make an argument, right, for lower maintenance cost and potentially a better return on your capital investment, right? Because the machine will maybe last a little bit longer, right?
Martin, you hit the nail right on the head.
Yeah, okay.
That's exactly what we do. And that is why OEMs do not like us. Mm-hmm. Because we make their products last so much longer. A compressor, a manufacturer give you 20,000 hour, you know, hey, runtime. Hey, you know what? Your compressor is going to last so much longer that they don't have to replace it. So now you're understanding why we're having so much issues with the OEMs. That's exactly why. And we are now getting demand from the end user. End user demand is going to change everything. And now that the carbon became a big problem for buildings, and especially cities like New York City, they want to electrify this industry. They want to move away from fossil fuels, no gas, no oil, no none. They want to use only heat pumps for both heating and cooling.
Right, they're doing that in California.
Yep, yeah. Same thing. What's going to happen? Those heat pumps are not even close to pump up 180-degree water that their infrastructure is set up for. Mm-hmm. So they need products like ours. They want to get creative by taking a lot of rentable space, by adding water tanks to make ice, capture heat from that process to influx that into the buildings. This whole thing is with the electrification movement. That is global, by the way. This is not only New York. We're seeing this same in Netherlands. We're seeing the same in Germany, especially now with what's going on with Russia. Okay, so now the understanding why we are sitting in the center of all these movements. That's why I don't have time to answer calls anymore. People calling, they want to learn more about our technology.
Yeah.
And we are guaranteeing 20% efficiency on any kind of HVAC equipment, closed loop HVAC equipment. We are guaranteeing.
So Berkin, okay, so let me kind of I'm putting my business owner technician hat on now. All right. So you're telling me that this product, if you've got a large industrial or large to medium sized brewery, let's just do that. You got a brewery, Budweiser, big guys, they use these monster chillers.
Yep.
And let's just say, you know, they're running a 50-50 mix of propylene glycol, PG.
Absolutely. Yep.
All right. So you're telling me that you can put this product in the same concentration, right? 50-50 mix. And you can provide the same heat transfer, scratch that. You can provide the same freeze protection. So 50/50, that gets you down to minus 30 on a PG system. You guys will give about the same freeze protection performance.
We increase that too.
Oh, the freeze protection. So what would your freeze point be at 50/50?
It's probably around the 35 minus.
Okay, minus 35. Okay, that's good. And then this product, minimum, you're saying, will provide a 20% better heat transfer performance than water.
Not only we're saying that, we're guaranteeing that, and also we're backing that up with a guaranteed 3-year ROI. So
that's my other question.
Yeah, so it's not only we're guaranteeing your efficiency, we're guaranteeing the ROI, and let me just increase the ante up a little bit more here. Not only we're saying that, but we're also giving you a guaranteed savings contract, guaranteed performance contract. So if the fluid does not perform, we're taking it back, which never happened, obviously. We're putting whatever you had it before.
Yeah, okay. Well, that's certainly a pretty compelling, argument. I guess the trick is getting the word out, about what you're doing. So have you, what's your target client for this particular product, Berkin? Like who are your early adopters that you've discovered so far?
Well, that's another great question. Thank you, Martin. The early adapters are usually the end users who have problems. You have we're not only look here is let me just take 2 steps back. When I increase your efficiency, you can either increase your COP, you cannot save money, but increase production. For example, we're working with I don't want to name the companies, but we're working with global level plastic injection companies, right? They make bottles. The bottleneck of every technology, especially in plastic injection, is the cooling time. You have this big molds that you have to cool them up. Once liquid polyurethane goes in there, and you have to cool it. Average, for example, bottle for Coke takes about 10 to 11 seconds to cool down. We reduced that to 9 seconds.
Well, yeah, because you have more heat transfer. Yeah, that makes perfect sense. Yeah.
So we're not saving money here, but we're increasing production capacity of a 24/7 running factory by 10%. What does that mean?
Hey guys, quick announcement. If you have not stopped into our website at skilledtraderescue.com, please do that. On the home page here, you will see that we have the Join the Movement email list. If you haven't signed up, please consider doing that. We have some amazing guests lined up for the podcast. I'm going to be getting the stories out of successful technicians and business owners in skilled trades. These are not just HVAC people. These are going to be from across the skilled trade spectrum. And my hope is that I'm going to be able to draw out of these people the things that have worked in their careers amazingly well, and the things that if they had a chance to talk to their younger self, what they would tell them not to do. So I want to share all that stuff with you. And if you sign up, you're going to be the first to know when we drop those new podcast episodes. Also, coming soon, we have the BEST workshop. It's a 5-day automated email workshop. However, you're going to give content to us through that workshop. You're going to get one-on-one feedback from our instructors, and we're looking to better your career. I've been teaching the BEST process for many, many years, about 2 decades, one-on-one, and I'm going to be trying to do that to the masses through this workshop. It's totally free. All you got to do is sign up, and as soon as you do that, you'll get alerts on your email as soon as these new podcasts come in, as well as the BEST workshop. So hope you check it out. I will put a link to the website on the show notes for this episode today, so check it out.
You know what that means,
right?
So right. It's the same thing for that is our very famous Virginia Polytechnical University case study. They had a problem. They had an AI required huge server power, and NASA donated 12 chill door rack high density units, which is a 50 kW. But guess what? Where do you have NASA? Houston, we have problem. Florida, launching pad. Virginia has same climate as Buffalo, New York, which we had no idea. Virginia.
I did not know that, but that makes sense.
And that's us over there. They came up with this the AI with limited space. They put glycol in there. They had dry clothes on the roof. Guess what happened? No more 50 kW, right?
Mm-hmm.
And we were working with Oak Ridge National Lab at the time for different heat pump technology. Anyway, so Oak Ridge National Lab recommended us to use, and they never questioned it. They purchased the fluid, installed it. This is 2017, and we were just starting back in the day. I was like, oh my God, Virginia Paul Technical is asking for product. We're rich.
Yeah.
This is going to be a phenomenal thing. And since then, they predicted Ebola virus's safe periphery, with this same AI that HydroMX is cooling it. And that's pretty much our claim to fame so far.
So you were out at Oak Ridge. Were you on the nuclear decommissioning side? Is that what you guys were on at Oak Ridge?
We signed a very strict NDA with them.
Yeah. Okay, yeah.
They needed help because they had to use glycol.
Right.
And you know how glycol gets, especially propylene, at cold temperatures, it becomes sludgy.
Yeah, you keep leading right into my questions. Okay. So let's dive into that a little bit. Okay, so we've uncovered that we can put this stuff in at the same concentrations. We get, for example, 50-50 mix. We have a -35, which is better than PG at least. EG probably close to that.
Yeah, EG 40.
Yeah. All right. So let's talk about viscosity, because that's the other issue. Like if you've got a low temp, we'll go back to our brewery.
My favorite.
These guys.
Martin,
what's that?
Martin, say no more. Let me just jump into it real quick.
Okay.
How do you measure viscosity? Dynamic viscosity, right?
Well, Cinepoise, but yeah. Okay.
Yeah. Okay.
Yeah.
What is that? That is for Newtonian fluids.
Mm-hmm.
Okay. What is our fluid? Our fluid is non-Newtonian fluid. Now let me get into more,
put that in English, would you?
Thank you. Paradigm shift questions. With nanotechnology, and anybody can Google this, the real viscosity measurement methodology is apparent viscosity. What is apparent viscosity? Apparent viscosity is for non-Newtonian fluids, whereby the viscosity of the fluid changes under stress conditions. They call it shear stress. Okay? So our fluid is a shear thinning non-Newtonian fluid. What that means is that under stress, which is under more pressure, you have, I love to give Empire State example, which I'm seeing it from here, from my office. They have 26-inch risers going up, 100 floor, right?
Mm-hmm.
That same fluid that you're pumping and at the end of the day is going through a 1/2-inch pipe. Yeah, you have on the coils. Right. That's the definition of a stress, okay, in the fluid. Our fluid gets thinner as you imply more stress. And the reason for that is our particles that we use. And although we have a trade secret manufacturing process, we opted not to use patent industry, which they completely demolished. I'm sure you know why.
Oh, yeah, I know about that. Yeah.
Yeah. The particles that we use are not metallic.
Okay.
We cannot use metallic particles in HVAC system.
Right.
Erosion is gonna eat up everything.
No, you're right. So, okay, go ahead. Finish your thought.
Our viscosity levels are a lot less than what you see on the mainstream heat transfer fluids. The number one names. And I can tell you this from our case studies. This is versus water, not glycol. We add not more than 3% pressure drop on any standard pump. Okay, so I guess, wow, that was like a biochemistry lesson right there. Let me think here. All right, so I'm going to break it down because I'm a simple man. So what we're talking about here is my brewery application. They're running, let's say they're running slightly above freezing. So let's say we're running 35, 38 degree glycol.
Okay.
Sure.
So at 35 to 38 glycol, I don't have my chart here, but because that propylene glycol is getting colder, it's getting thicker. That's just, and EG works not quite, it's not quite as bad as PG, but you're adding viscosity, which means you're adding pressure drop to all of your heat exchangers, which means you have to ramp up your VFDs on your pumps to overcome that additional back pressure. And what you're saying, if I'm understanding you correctly, you're saying that even though you have the freeze protection, again, we'll use our 50-50, we have a freeze protection all the way down to minus 35. As you get colder, you're not seeing that increase in pressure drop or viscosity. It doesn't happen in nano, right?
With propylene, let's start with propylene.
Yeah.
Propylene glycol is a trouble product. Okay.
Yeah, sure can.
And industry. Let me just take another 2 steps back. Governments, the decision makers on what's toxic, what's not, what can be used, what cannot be used, they don't really understand this technology, right? Propylene, yes, you can, it's better than ethylene, no doubt. But once you add inhibitors, which you have to, to any propylene solution, that becomes non-toxic automatically. Becomes toxic automatically. It was non-toxic, now it's toxic because of the inhibitors. Therefore, in New York now, you have to reclaim even propylene glycol solutions.
Because of the nitrites, yeah.
Because of the nitrates, the molybdates, the potassium phosphates, what have you. All right, they have to reclaim that now. Well, let me just go to an example. With breweries, which we work with a couple of them, okay, we kept our promise. It was, again, engineers, their problem was they love to simulate things. Any technology is not simulatable. I don't know, is that a word? It's no good for them. You know why? Because they're new breed engineers. Mm-hmm. And they believe the simulation thing that there is no tomorrow. Unfortunately, the parameters of a nanofluid, surface area increase, ionic exchange capacities, are not in the simulation programs. What you have is standard stuff: conductivity, specificity, viscosity, and density. That's it. Mm-hmm. All right. But the way nanofluids work, that's why every time I talk to a nuclear physicist, they get it immediately. Well, let me ask you a question. Do you think is there a difference between a DI water and a regular tap water when it comes to heat transfer properties?
Not really. As far as I know, it's just water with the ions pulled out of it.
Well, they pull out minerals. That's why there's no, they call it ionic exchange, right?
Right.
Well, you just cost your customer 6% efficiency.
Yeah.
By using DI water. DI water is no good. Nobody should be using DI water. Why are they using it?
No kidding.
Because heat transfer, because the chemical treatment companies can sell you more inhibitors.
Yeah. Well, yeah, the inhibitors, they need to be in there. The nitrite, especially nitrites, are going to coat your pipes, right? And because most customers will fill these systems, the water component of their water glycol mix is just going to be water out of the tap. And depending on where the municipality gets their water from, you could be getting, I'm going to use a technical term here, a crap ton of minerals that come in with that water. And if you don't have a inhibitor in there with that glycol, you're going to destroy your plumbing, right? Because that stuff falls out of suspension and then it starts schwacking all the metals of all the systems, and pretty soon you've got a rusty system, right? So you're saying that this nano stuff in itself provides the same plumbing protection, if you will. If they use city water and your product, this nanotechnology is also going to prevent sloughing of the ferrous metals in the system, correct?
Yes. I'll take you one step further again. None of the, again, names with glycol industry has the level of corrosion protection that we're having.
Mm-hmm.
The toughest corrosion test on the planet is a Buell cert test for old boiler systems in the UK. And
Mm-hmm.
NSF America, NSF.org, acquired Buell cert, and we have a Buell cert corrosion certification. And we're not using nitrate. We cannot use nitrate. Our main chemical is molybdate, and molybdate is superior than nitrate, also expensive.
Mm-hmm. Hey guys, I have an exciting announcement. We just recently made some updates to our 3 most popular online courses at processchilleracademy.com. If you're a technician that's looking to improve your skills a little bit, maybe get some specialized training to give more value to your customers and your employer, or if you are an employer, a contractor that is looking to augment your existing in-house training with online training that can be accessible from any device, this is a really great opportunity. Just go to processchilleracademy.com, just scroll down on the homepage and you will see the course area. If you go into the course page, you will see that we have currently, for a limited time, we have a promo code of Chiller Pro that will save you 25% on any one of these courses. So I hope you check it out, and I'm looking forward to seeing you in class. So how about, okay, so let's say we have a customer that's willing to be an early adopter of this stuff, right? What is a good starter? So let's say you've got a large industrial client, and here's, and I'm sure I'm probably preaching to the choir here, but you've got a large facility manager, a Microsoft building, an Intel building, a big shopping mall, something like that. That facilities manager, he doesn't know you guys. He may know one of the other manufacturers I won't mention. And, what's a good channel for someone to test out this product, do a live demo test on this without the risk? Because, these facilities managers, if you've got like 1 million square feet, you're not just going to willy-nilly take out all the glycol.
Absolutely. Well, let's start with the risk. We have a full product liability insurance that covers every piece on any building that HydroMX touches. What does that mean? We have something nobody has. We're not only backing up our efficiency claims, but we're also backing up our corrosion or any other system damage with a full liability product insurance, which we carried for over 10 years now with 0 claims.
Yeah.
0. And
I think Go ahead.
The channel is, well, we have our website. We have an info@hydromx.com email. Anybody can drop an email. We're getting over 50 emails a day now. Our people, we have pretty much distributors everywhere, pretty much on modern world. With some of the distributors, we'll contact you and we'll take it from there. Mm-hmm. And Mark, believe it or not, just yesterday, after 3 months of collaboration, we just signed the very big contract with a marine engineering company called Avantis. And I can come out and say it right now. And to my surprise, those ships, container ships, cruise ships, they make up around 5 to 10% of entire global carbon emission. Mm-hmm. Right? So now we're covering also the seas, not only land. So that's how it works.
Okay, so let's say again, I'm really speaking to the facilities managers out there. So let's say you get a facility that they want to go ahead and give this product a shot. They get approvals to do it, and they what's the transition process? I mean, it's going to be very difficult on an existing system to get all the existing water and propylene glycol. No. What's the process on that?
It's not difficult at all. Actually, the reason why we're so popular right now, because HydroMX is a non-intrusive technology.
Okay.
All we have to do is swap the fluid. Swapping the fluid for many buildings in New York City is a twice yearly event. They drain their systems and they refill them, right?
Right. So if there's a valve that gets left closed and you've got a couple of heat exchangers that for some reason they didn't drain down, still contained the regular PG or EG water mix,
That's fine.
That's not going to be a problem.
No, we can. Martin, we've been doing this for over 10 years now. We know what we're doing. And then the process is going to be as follows. We reach out to them, sign a simple NDA. They will forward us their energy bills. And we're going to calculate the volume of the system. And we're going to give them a proposal based on the volume with the guaranteed ROI. Just like we did with the Empire State Buildings. We just installed 3050 Broadway. If anybody is familiar with Manhattan, that's one of the iconic buildings. We just replaced the entire chiller system with HydroMX.
Right. Okay. Yeah, this is interesting. So full disclosure, guys, to my audience out there, before we recorded this session, I asked Berkin about issues with the refrigeration cycle. And I'll let you chime in here, Berkin, but what I see here is that there is no issue according to the documentation. I went through some of the case studies that HydroMX has on their site, and they do have this stuff running in a lot of process chillers out there. And so I'm assuming that there's no issues with the expansion devices dealing with the extra capacity that's coming out of the heat transfer fluid. So that's good to know. I mean, did I pretty much nail what we talked about before we hit record?
Beautifully, Martin. Thank you so much. That's exactly correct.
Okay.
One of the, I can give you one of our other claim to fame case studies with Slovakia. Slovakia Continental Tire Factory. They had an issue with their chillers not being able to maintain the set temperature that they require. They heard about us. We gave them the fluid. This was 4 years ago. They're adding another HydroMX loop to their factory next month. So not only that, we have repetitive customers. For example, we have this generic drug manufacturing company called Microlabs out of India. They installed the first factory. This was 6 years ago. They measured and verified it. They did themselves. They measured it for 1 full year. Now they installed every other factory without even measuring it. They have 5 factories. So I guess repetitive customers speaks for themselves. Right. If we had not accomplished what we are promising, I guess we would not be getting repetitive customers.
Yeah. So is there a minimum, what's the availability on this stuff? I mean, have you had any supply chain issues or anything like that?
Oh, man, that's...
that tells it all right there.
Oh, boy. With propylene glycol, the lead time is currently 4 months. With ethylene, we're a lot luckier. We did some inventory already stocked up. But with propylene, we just ran out because we had a big customer now out of Minnesota. And looks like Minnesota is converting all its schools to probably HydroMX pretty soon. So we're just getting a lot of demand for propylene product. But propylene is really hard to get right now.
Yeah.
It was easier in Europe because Russia has propylene manufacturing facilities. But now that's going to be problematic too, the way it goes.
Yeah, that Russia's out of the loop for a while. No pun intended. So what's I guess what I want to find out now is we have a lot of process chiller companies out there. And when I say process chillers, I'm talking chillers that are under 150, 200 tons. They're smaller for, specific mission processes out there. And do you guys, assuming, once your supply chain challenges get resolved, do you guys have a minimum, or like you ship a concentrate, which is pure, right? And then the customer, okay, that's a big deal. So they can buy a concentrate and then they mix it within the equipment. What's the minimum quantity? Like if I've got a little chiller manufacturing company, which I used to have, and I want to start promoting this product to my customers that are buying chillers from me, can you buy this stuff in 5-gallon, 10-gallon, 55-gallon containers?
Yes, thank you, Martin. Yes, we go down to 5 gallons. We prefer to ship in totes. Their totes is about 1 metric ton. which is about 250, 238 gallon, whichever the product is, ethylene or propylene based. We do also 55-gallon drums.
Right.
But we can pretty much, I mean, our factory is designed to address any quantities.
Okay. Now the ROI though, you're going to pay more per gallon of it. So you mentioned a 3-year ROI. What's the quantity you have to buy to get that kind of ROI? It's going to be more if you're buying smaller containers, I'm sure.
That would be, we don't go lower. If we're doing the engineering side of it, obviously we got to put some time into it with our engineers. We don't do that for small projects. Anything less than 1,000 gallons is not appealing to us.
Okay. Well, that makes sense. Very good. Well, this has been really educational, Berkin. I think this definitely has merit. I think it should be considered. I guess I'm a little. I'll remain hopeful that you find some more early adopters. And again, once you get critical mass, nobody wants to be first on something like this, right? Or very few people want to be first because they don't want to take the risk. But if you get a good,
modern. We kind of passed that stage right now. We're not looking for early adopters. We're looking for building owners, engineering companies, especially design engineers that want to improve their designs. We can lower the footprint of an equipment with a nano fluid. And now let me for retrofit end users that we have to swap the fluid. I have great news for them too. For data centers, any glycol fluid, we can do now what we call an injection, Martin, whereby we don't have to swap the fluid, but we rather inject around 5% volume of the system, what we call a techno package. We have over 10 case studies globally where we implemented this technology, and it's working marvelously.
So what do you mean by inject? So you basically are you purging the regular traditional glycol and then injecting this stuff, or what do you mean by that?
Let's say you have a data center, right?
Right.
Which I cannot swap the fluid because of downtime. It's not ideal. It's not possible for most data centers, correct? So what we do is we come in, we analyze the system. We're hoping that your system is clean chemically.
That's wishful thinking, but go ahead.
For data centers, we are more hopeful on that. They pay money, right? For water treatment. So what we do is we take a sample of your fluid, we analyze it, we come up with the ideal concentration to inject, meaning to slowly, gradually dose in our techno package to your existing system with no downtime, and we're still guaranteeing you 20% efficiency. How about that?
Well, wouldn't you be so you're going to have to purge some of that fluid to put some of the new fluid in, right?
There's no fluid now. It's only less than 5% of the entire volume I'm replacing.
Okay, I see what you're doing. So they're going to have to drain down 5%.
We're not taking care of everything. There's no draining down either. It's just a little bit complicated process. Depends what they have.
Okay.
5%. We did the lowest we did was around 3%. Fluid. We're taking some fluid out, and we're gradually start putting in the nano package to the system.
Interesting.
It's a one-day process for systems about, I would say, less than 5,000 gallons.
Okay. There's a lot of systems out there like that for sure.
Yep.
Yeah.
One-day process. That's it. No downtime.
So, Berkin, how do people find out about more? I've got your website up here, HydroMX.com. So if somebody wants to get more information about your products and your solutions, what do they do? Just go on to the distributor list? What's the best way?
Yep. Drop us an email.
Okay.
Don't call us. Drop us an email, please.
Okay. Wow, that's really good. Well, gosh, I can't believe it's been 45 minutes. Yeah, well, thank you so much. Is there any last words you'd like to send out to our audience out there, Berkin?
They will be hearing about us in a grander scale and pretty much 6 to 12 months from now. And we're proud to be representing Nano-Technology.
So that is it. I hope you enjoyed this episode. I very much look forward to continuing to connect with you. Please don't hesitate to send me messages on LinkedIn. I'm on there all the time. Or you can reach out to me on my email. I'm at mking@processchilleracademy.com. And until next week, when I give you the next installment, I wish you a great week, and I will connect up with you again soon. Take care now. Bye-bye.